we shall deal with the solid state. Solid state. So what are the how to crack this solid state? How to crack this solid state? What are the important things that are to be covered? Let us first try to know the headings that are to be covered in the solid state. Now, classification. First thing is classification of the solids. Classification of the solids. So classification of the solids means in this there are, what is the broad classification? Crystalline and amorphous. Crystalline and amorphous solids. And crystalline solids will have the definite pattern of arrangement of the particles, definite melting point and boiling points. They will be anisotropic. That is, the physical properties will be different in different direction. That arises due to the difference in the pattern of the arrangement of the particles. Amorphous will not have sharp melting point. The regular pattern of arrangement is limited to short range, and in this case they are isotropic, that is physical properties in all directions will be similar. After that, types of the solids. Crystalline solids can be divided into molecular solids, ionic solids, metals and network solids. So we have to know about these things: molecular solids, ionic solids and metals and network solids. What should we know regarding this, the type of the solids? What are the constituent particles, how they behave, what is their electrical behavior, and all these points. What are the examples for molecular solids? We have to know what are the constituent particles. Under the heading the types of the solids, what are the points you have to remember? What are the constituent particles? What is their electrical behavior? What is their magnetic behavior? These points are to be known regarding the types of the solids. After going to the types of the solids, after going through the types of the solids, because we can expect theoretical questions in the introduction part also. Next we have to go to the unit cells and space lattice. What do you mean by space lattice? The pattern of arrangement of the particles in 3-dimensional region or 2-dimensional region is called space lattice. And unit cell, what is unit cell? The smallest geometrical portion which on repetition generates the entire lattice is called unit cells. We can have unit cells in 2-dimensional region, in a 2-dimensional region and a 3-dimensional region, 3-dimensional pattern. Now in our present discussion we will mainly discuss about the 3-dimensional unit cells. What are the important 3-dimensional unit cells we have? We have face-centered FCC, BCC, simple cube, and end-centered unit cells. So we will mainly, our today's discussion is mainly will be focused on the analysis of these types of the solids. After coming to know the types of the unit cells, we have to discuss about the analysis of the unit cells. Let us briefly discuss what is the analysis we have to do regarding these unit cells. What is the analysis of the unit cells? Now, the first point is cell constant. Cell constant. What is cell constant? Number of the effective atoms per unit cell. Number of effective atoms per unit cell. In FCC, what is the number of effective atoms? 4. In BCC, what is the number of effective atoms? 2. And in simple cube, what is the number of the effective atoms? 1. In end-centered cube, what is the number of the effective atoms? 2. Number of effective atoms. In FCC, the lattice positions are being occupied by 6 faces and 8 corners. 6 faces and 8 corners will be occupied. In BCC, 1 center of the body and 8 corners will be occupied. In BCC, 1 center of the body and 8 corners will be occupied. In simple cube, only corners are being occupied. In end-centered cubic unit cells, apart from the corners, 2 centers of 2 alternate faces will be occupied. This calculation is important